Good morning, folks. In today's short video, what we want to discuss is the integration that DataOps Suite has with the Databricks system as a whole. There are multiple points of integration, so I want to quickly touch base on most of them to give the end users a bit of preview of what we're capable of. But before we get into it, what I want to start with is where exactly these validation processes come into play. Just as a recap for anyone who just joining us in here, Datagaps is a toolset, a suite of toolsets that provides validations for data quality, for ETL, for BI, and a lot more. And when it comes to data ops as a whole, the process that we want to ensure and what we want to achieve is that if there are new requirements coming in, or if there are requirements which have been altered, as a developer is going to create a fork and work on the changes, the QA development and the QA personnel should not spend too much time creating the test cases. This test case creation should be inherently automatic. It should be based on the requirements itself. And this test case creation should be a kind of recursive process where the reports can be sent back to the developer, telling them exactly what's going wrong with their current iteration of their functional test cases. Basically, what's going wrong with their code based on what's being expected in the requirements. This process can then be repeated across multiple branches, and we would like to reuse test cases here as well to save a lot of time for the end users and make sure that any kind of code change or inherent functional deployment of any particular type of code, be it transformation, migration, or BI related code, is actually validated throughout the entire pipeline. That is what we would like to aim for. And where Databricks comes into this is in multiple facets. Of course, one of the key pointers of where Databricks comes into our application is primarily as part of the engine itself. So the application can actually run within the Databricks engine as part of the system itself. As we see, the application can actually use Databricks as an engine where all the processing of the data is going to take place. In terms of QA, it implies validation of transformation logic, validation of data quality rules across the entire data set or at incremental loads. Either ways, the application can use Databricks as an engine, and the application can also use Databricks as a source of data sets from where we can pick up these data sets, be it the one landing in your bronze layer or be it the one being pushed out into your golden layer. Now that we have discussed our integrations with Databricks in terms of data and sources, let's discuss the next part, which is integration in terms of Databricks itself. So what you have on your screen is a typical Databricks install. Now here, what we want to focus in on specifically is catalog and our support with Unity catalog. As you can see, the application has defined what these connections are. As an end user, you can define them yourself because you might ingest data. You might define them in your own way right there. Once these definitions of tables and views and their correlations have been defined, the application can directly get into the system and pick this up as is. As a sort of illustration, I can open Mapping Manager, which kind of showcases this specifically. Within Mapping Manager itself, I can define what my source and target mappings are, and most of these things are picked up inherently. I can import multiple tables directly using my existing connections. Of course, that's the easy part. We have just picked up the connections from the main system, but how is this helping us with our data quality and how is it feeding back into Databricks as a whole? Well, that's where I'd like to go back to our deck and kind of showcase exactly what we want to discuss. Say the example that you're working with is the problem statement of focus as well. What you see on your screen is basically a depiction of an ETL mapping tool or ETL mapping document itself, and where exactly these tables of the target table come from. Basically what our sources and what our targets are. On the left, you have the transformation rule, which tells which columns are being combined or transformed into the new target columns. And on the right, it basically tells which particular set of tables are these particular set of columns coming from. Now we discuss a very important point of white box and black box testing. White box testing is pretty straightforward. Let's take into example the column first order at right there where my mouse is hovering. This column is basically defined as the earliest date in which a customer has placed a particular order. That's it. That's the only thing given in the requirements document. And so when we look at MDL customers, we need to ensure that this particular date for a particular customer is in fact valid. What we're doing here is validation of the transformation logic. However, say within stage customer and stage orders, everything is fine in terms of duplicity, but MDL customers certainly has duplicates. That implies that, well, while the transformation is completely valid, all the functions are working as expected, there have now been duplicates introduced into the system. And validation of the data in this terms is called black box testing, because you don't really need the transformation logic in order to validate if the data is valid here in terms of, say, duplicity, unicity, business rule validation, and a lot. Our application works on both of these principles. For white box testing, the application has the capability of picking up these transformation logics and recreating that logic within SQL to then do a source to target comparison. Let's see this in action so that it better illustrates what our problem statement is. Here within the application, you see that we have the exact same use cases between the most recent most and the oldest one between first order dat and the last order dat. And the application can then be prompted to generate transformation checks using Gen AI. Gen AI here is not connecting to OpenAI per se. You can connect it to a box LLM or the LLM that comes with the product itself. And since the product is installed within your infrastructure, since SaaS here is optional, you can ensure that even metadata and other facets are not being shared outside your system. Our application is worked by a lot of, say, financial customers, healthcare customers, as well as holding parties. So we ensure that none of these particular functions, metadata, or any other facets can leave a particular isolated system. More on that later. If you want to discuss that, feel free to get in touch with us. Of course, here what we see is a very important use case. So what we have done is that we have applied the minimum and maximum orders because, well, that is what the description defines itself. And now let's actually see this in action when we do a source to target comparison. I've already created this test case, and what this results into is that we have applied this transformation to our source files, and we have picked up the final MDL files as we had discussed earlier. And now when we do a source to target comparison, we see the problem statements lie that, hey, for about 7% of the records, everything seems fine. But for 90% of the records, the mismatches are present, which illustrate that the first order created by the developer in the MDL customer table does not match what the requirements was asking. Now, this could be for a plethora of reasons. This could be that when the developer created these particular set of orders, maybe they were adding extra flags to define certain categories or certain date values only. Regardless, these extra flags were not present in the requirements document, meaning that when an end user tries to look at the first order, he or she is expecting the true first order. And so in this particular way, what we have defined is that the transformation within a particular, say, ETL mapping has not been done correctly. And this is white box testing. Let's pick up the next one and what we discussed with black box testing. Luckily for us, black box testing can also be done with the click of a button where the application can create a plethora set of data quality rules for the end user. These could include everything ranging from ensuring that the data is accurate to the data is valid, making sure there are no nulls within key columns, and also making sure that there are no negative values within the system. This is, of course, making sure when the transformations are also working as expected and there's consistency between data sets. But as you can imagine, there are a plethora of dimensions across which you can do these test cases, and the application tries to create all of this from the get-go for the end user itself. If you want to, you can define your own traditional set of rule sets from the templates defined. There's an entire webinar done across this, and this goes pretty deep, as these set of rule sets can be used by a variety of use cases, be it insurance data validation, financial data validation, logistical data validation, and a lot more. The rule sets themselves can be imported and exported, but the main gist that I want to focus in on is when these rule sets are actually run, there's results being generated. There's, of course, a lot of things being done at this point. Well, the first thing that happens whenever we do this kind of use case, and I'll use an example to illustrate further on what happens, is that the application is going to segregate your good and bad data for you into data sets. That is what you see on your screen right now. These are data sets, not just preview records. So if you want to go ahead and make sure that your preview or, say, the mismatches are actually defined within your system itself, within your Databricks tables as a proper mismatch, and you want to see a proper dedicated column showcasing exactly why this particular record is deemed as a mismatch, you can have that. Here you see that the first record has been defined as a mismatch because the quantity validation has failed, as well as the reference order pattern. Looking through the record, we see that the quantity is more than 100 and the reference order ID is a 4-digit number. And going back to the rules, this is exactly what we wanted to avoid. We wanted to make sure that our reference order is a 5-digit number, and we also wanted to make sure that our quantity is between 1 and 100. And so the application has distinguished them as good and bad records as data sets for the end user to use. And there's also data quality scores that's generated within the system itself at a overall, say, segment rule level, all the way to a data level. And of course, all of this kind of summarizes itself. If we just move into a nice Jaffle shop example, all of this summarizes itself into a proper DQM score across multiple models, or in this case, across multiple layers. So as an end user, you have this within the application. But say you are working with, say, other developers, and developers want to see this. Well, not to worry. Within the the Databricks dashboards or Databricks catalog itself within the data quality system, you can associate dashboard and data quality rule sets, which tell you across multiple runs or across multiple systems itself what is a data quality score. Of course, the data sets themselves can also exist within the catalog if required. This is just an illustration of the fact that the rule sets that you're running can be directly linked with your Databricks system. So now, maybe you're not a QA developer, maybe you are reporting to say 10 developers as well. You're working with 10 developers, and now instead of them going into Datagaps or DataOps Suite and trying to figure out the navigation there, they see a dashboard which tells them exactly what this particular data set is. We're using the catalog, using the summaries there. And within the dashboard, they can also see exactly what rule sets have been run, how the data has been validated, and how the data has been looking over the past, say, multiple runs or over the course of different rule sets as a whole. Dimensions. That is basically kind of a short overview of integrations. This is still the tip of the iceberg. We have a lot more to define in terms of the engines, in terms of using auto-scaling features, in using Kubernetes and other systems, as well as integration of catalog to use an agentic AI agent to create these rule sets and also work with debugging any kind of issues that you might have faced. So all of this and more can be found at datagaps.com. So feel free to get in touch with us. Once again, if there are any issues, let us know. Thank you.